So I'm going to speak about very simple things, and because everybody knows what is coffee. So my name is Andrei Zagorodny. I work with LabVIEW for quite a long time, and my main interest is software architecture. I work for Novator Solutions. This is a middle-sized company in Stockholm, Sweden. We have different divisions, production, we sell our products, but I work for consulting division, and it means that I work with different projects, with different customers. So, and I'm going to speak about parallelization. I said it is very simple subject. We always parallelize, and we always parallelize main loops of our software. But we rarely parallelize small chunks of execution, and we do it only as last resort. Now, what are small chunks of execution in context of this presentation? It is VIs, which don't have main loops or state machines, so they just executed from beginning to the end. And now how our typical software looks. We click Start. Software does some initial execution. After that, we parallelize main loops for, let's say, for each unit. Each class here represents one unit. It is a hardware unit or software something. When we end our day, we click Stop, and software must execute something more. And because we speak now about initialization and deinitialization of our software, we have here steps: initialize and deinitialize for each unit. So let's call it initialization and deinitialization steps of our execution. And I will speak mostly about initialization, but it's only a very good example of a need to parallelize. What happens when we start initialization? We have to, first of all, initialize our hardware. Step motors, each of them must find its 0. Some units must search for counterparts like Bluetooth, or environmental control, for example, bring chamber to temperature or vacuum it or whatever. So our scheme, we come to work and we are having the most productive time. Why we have most productive time? Because we have adrenaline of our blood. Why do we have adrenaline in our blood? Because we just were listening for alarm clock. So we are ready to work, we click Start, and we wait. We go to drink coffee. At the end of the day, we want to go home. We click Stop, and we cannot do anything until the system is ready to power off. We go and drink coffee. And the question is how to avoid it. And the problem is usually even limiting us in some sense. Why? Because a lot of LabVIEW projects, almost all my LabVIEW projects were starting from very small projects where initialization and deinitialization didn't take time at all. But customer wants, okay, it's very good, add something, add more servo motors, add temperature controlled chamber, whatever. And when I come to the situation when we need to optimize initialization, deinitialization time, it is time when we have only refactoring in our hand. We cannot change architecture. Architecture is already decided. We have no resources to rewrite anything. Solution to parallelize everything, and it will not work, because we cannot start everything in parallel, even in this scheme. So say, okay, we initialize in parallel, after that run in parallel, initialize in parallel. Why? Step motors start to move. If they move all at the same time, without knowing where they are, they will collide. So high energy sources, we need to initialize safety systems first. Otherwise, we have a problem. What we do, we parallelize what we can parallelize. And this is, it's not a spaghetti code yet. yet. Why? Because it's not enough. In advanced system, we have maybe attachable units or licensed units. Or very often, we have many workstations with different assemblies of hardware. So simplest solution use case structures. And here we have perfect spaghetti in our plate. Empty classes, little bit better, but not good at all, simply because with empty classes, we have the same situation. We have the whole code in our big bunch of the software, and we want to be flexible. So we usually start main loops, not with in one block diagram, placing them under each other, but we start them asynchronously. Why don't we do the same with our initialization? But if we do the same, we cannot keep them as small chunks of execution because they must communicate with each other. They must have open state machines. And it means we have maybe 100 different classes and we need to rewrite every of them. And they're more complex and unnecessary. They all hang in memory, just waiting for each other. Only few of them maybe are doing something useful. So we need some kind of abstraction. And we have these classes representing our units. But the units are already implemented. These classes certainly have open superclasses. I don't show superclasses here, but these classes can belong to completely different structures of class hierarchies. So we introduced an interface. And interface, I call it initializable units. And what does this interface? Oh, I forgot to mention that I use group4. It means by ref classes, but concept is fully applicable to native by value classes. But as usual with by value classes, you have to work more, but it is not a question of this lecture. So, what is interface? Obviously, it must have two methods, initialize and deinitialize. It is obvious, but at the end of the lecture, the interface will not have these methods. And how the initialization performed? We have a machinery. Machinery has a black box here, which decides which unit can be initialized next, and actually take it from removes it from the feed array and initializes. And of course, it is not parallelization at all. You see it. Instead of it, we must start them asynchronously. And of course, some of you is already smiling because this code is not functional. It is just illustration of the concept. But let's continue illustration in the concept. Why don't we use superclass? Just let's say we want to have, instead of interface, we want to use superclass. How? We speak about concept now. We need three attributes here. One is unique name for the unit. Second is state of this unit. This is initialization state. It's not state of the main state machine of this unit. And we need array depends on. This array contains list of units which must be initialized first, like safety before laser and so on. Black box. What does black box do? There is no black box in real code. There is a little bit more complicated, but still very simple initialization machinery. So we feed our, now it is a map, it's more convenient than array of our units, initializable units. Each unit, first step, we iterate through all units every time. So we check state of this unit. If state is not initialized, we check pre-requirements. If pre-requirements are fulfilled, we call method start initialization asynchronously. And this is method which must be in our interface or class now instead of method initialize. So methods initialize must be in each unit, but not in our superclass. For fun, we can get it there to get a little bit more beautiful structure. One very useful thing here is a case structure with some kind of global flag indicating where we put this flag on if initialization of any unit is not successful. Why? Again, to save time. If initialization of one unit is not successful, we must not start initialization of other units. Otherwise, we can wait for timeouts for very long time. Check pre-requirements. Here, we loop through all list of depends odd units and check their state. Such unit must be initialized or must absent. Must be absent. If it's absent, it's okay to initialize without this unit. If all of them fulfill the requirement, we can continue. Now, what is implemented in each unit? This is initialize VI. So we have a black box. Sorry, black box is already used. It's green box. So green box, which is specific for each class. This is where initialization code is placed. And this green box reports success of initialization to code of the superclass, which is quite simple. It checks success of initialization and checks for error and reports it. Reminder, when we do initialization, we very often create references. But reference lives as long as creating process lives. And we speak about very short executions. I use reference factory. So if a unit needs to create references, its green box will have something like this. It is a requester. Same for all of them. So we send a request with upper sub VI. This is some queue which is controlling the reference factory. Yeah, I will show it. And we send request, optional parameters, and disposable queue, reference to disposable queue. And our machinery here reads the request. It has, this is a case create reference. Of course, it is specific for each request. And there is a blue box now, which creates references and reports result, positive or negative, to our disposable queue. It's it. Simple, but not good at all, because again, we must have code for creating references for each unit in this machinery. We do it simpler. So we create second interface, reference requester. It has only one method, create references. And we override this method in each class. Our request method, which will look even simpler, instead of sending request text and optional parameter, we send the object itself. And machinery reference factory is much simpler. It simply calls this method, create references. Creating references is encapsulated in the same class, but reference factory runs in open thread or in main thread of the program. Much better. Now, lifetime. Methods initialize. They live very short time, only time which is needed for initialization with particular unit. They can be reentrant if we have units of the same time or not. Initialization machinery runs only as long as initialization is completed, but reference factory must live the whole time of the program execution. Now, our initializable class. What to do about it? We like to have class, but we can have a subclass can have only one parent. But we like having attributes. Moving all these attributes to subclasses will be actually crazy redundancy and crazy work in all subclasses. So we probably will have even more attributes, not only depends on, but depends on for initialization and depends on for deinitialization. Maybe we want to have some advanced reporting of the initialization process. So, but a class cannot have two superclasses. Is it so? No. We can have two or more superclasses. We can have so many superclasses and so complicated superclass structure as we want. But solutions are a little bit different. The basic principle is the same, but a little bit different for group 4 classes and for native classes. I presented the concept of the multiple inheritance in GDevCon 3. I cannot, there is no time to repeat this lecture. I would love to. So the title was From Interfaces to Full-Scale Multiple Inheritance. After that, I talked for 45 minutes and said thank you. You can find the lecture on YouTube, or the same lecture is available, you can find it through GDevCon 3 archives. There is a website where you can download toolkit for creating multiple inheritance with group 4 classes. The website is very simple to memorize, azetainterface.net. Azeta is my initials, so somehow I assign it to myself because I did it. So, and if you have any questions, this is my email, but one thing, please write meaningful subject, right? It is a question about multiple inheritance or Azeta interface package. Why? Because if I get email which I cannot recognize, so who is it and what is it? I don't remember your emails, unfortunately, so by heart. So I can put it in long list for reading. So, what to do if you work with native classes? No problem, redundancy, but not very big. So move the attributes name to your subclass. I call it unique name now in this particular unit. And in your interface, you create an abstract method, get unique name. I will write this method in each subclass. Redundancy, but what can we do in this situation? In the superclass, it's interface which we convert to superclass. So we have a loop with non-initialized shift register, typical for functional global variables, and map of attributes. The map is controlled by the key unique name for the unit and contains clusters with attributes for each unit. So we have all attributes but unique name in this VI. Now it is class because the main difference between class and interface is presence or absence of attributes. So coffee, we don't need to drink it anymore because our initialization and deinitialization are much faster. So instead of sitting and waiting, we can work more and still go home earlier. Or, as we do it here during this conference, go somewhere with our friends. Thank you. Will be questions, or I believe it's very simple.
Thank you, Andrei, for an entertaining presentation. So just a quick comment that you mentioned that we need to place those properties as attributes on a higher class, and that's why we can't use interfaces. Is there anything preventing us from just having an interface with an abstract getter, and then we don't care where that value comes from? I mean, you could still implement it as an attribute, but
this is what is suggested. We have abstract getter for name, and we have getters for all other attributes. I didn't put them here just for the sake of simplicity. In real class, I have getter and setter because accessing the functional global variable method is a little bit confusing. So if you start to implement immediately, you understand it's not only get and set there. You must create attribute for this particular class, and probably you must dispose it when it's not needed. So, but generally, yes.
Right. Okay. Thank you.
Thank you.